This lesson is about solving double or multiple angle trigonometric equations. So this is solving trig equations where the unknown angle is like 2x or 5x, or in the case of our example, 3x. For these sorts of problems, we need to consider the period of the function when we're finding or generating all the solutions within the domain. If I look at my graph to the right, this is x versus cosine of 3x. I can find all the places where cosine 3x equals minus a half by drawing a horizontal line at minus a half. And I can see that between minus pi and pi, I'm expecting to get 1, 2, 3, 4, 5, 6 solutions. So let's go ahead and try and find those solutions. Just like when I'm solving single angle trigonometric equations, I need to first find what my basic or acute angle is going to be, which I'll draw into my unit circle diagram. So I want to find what angle gives me a cosine of a half. I'm ignoring the negative at the moment. That'll come about when I draw my diagram. I can use my graphics calculator, or I can draw one of my exact value triangles. I'll find that cosine inverse of a half is pi on 3. That's my basic angle. I'm looking for where cosine is negative. So I'm going to state the quadrants where cosine is negative. From your cast diagrams, you should know that it's negative in quadrants 2 and 3. So we can draw up our unit circle diagram, and in quadrants 2 and 3, we're going to mark an angle of pi on 3 radians to generate some solutions. Here's 0 radians, here's pi radians. My two solutions are pi minus pi on 3, pi minus pi on 3, and pi plus pi on 3. But remember, I'm solving an equation for 3x. So these solutions are actually 3x. I can now simplify my solutions here. So I really have 3x equals either 2 pi on 3 or 4 pi on 3. So my solutions for x, which is what I'm trying to find, I'll divide everything by 3. So 2 pi on 9 and 4 pi on 9. And what I've found are these two solutions, 2 pi on 9 and 4 pi on 9. Those two angles, those two x values, which when multiplied by 3, have a cosine value of minus 1. So just like in the single angle equations, if we want to find more equations, from here we'll add or subtract the period. When I look at cosine 3x, I notice that it has a b value of 3, which means that its period will be 2 pi on 3, 2 pi on b, and I can substitute in 3 to get 2 pi on 3. So I've found these two solutions. To find these additional solutions, I'm going to need to add 2 pi on 3 or subtract 2 pi on 3. So my period here is really 2 pi on 3, but sometimes it's helpful to think of it having a same denominator as my solutions. So if it was on 9, it would really be 6 pi on 9. So that'll help me do my addition. So now that I'm trying to find all my solutions, I'll put my two original solutions in the middle, and then I'll start to add or subtract the period, which I'm going to think of as 6 pi on 9. So to these first two solutions, I'll add 6 pi on 9, and I'll have 8 pi on 9 and 10 pi on 9. Compare these to my domain. My domain was between pi and minus pi, which in fractions of 9 would be 9 pi on 9 or minus 9 pi on 9. So 8 pi on 9 was okay, but 10 pi on 9 was too big. In the other direction, we'll subtract 6 pi on 9. So subtracting it from both of these in turn. So first from 4 pi on 9, if I subtract 6, I'll get minus 2 pi on 9. And subtract it from 2 pi on 9, I'll get minus 4 pi on 9. Check it against my domain. Yep, they're both good. Since I haven't had to reject any solutions yet, I'll again subtract 6 pi on 9 from both of these solutions. So from minus 2 pi on 9, I'll subtract 6 pi on 9, I'll get minus 8 pi on 9. And from minus 4 pi on 9, I'll do the same thing and get minus 10 pi on 9. From here, I'll compare my new solutions against the domain, which should only go down to minus 9 pi on 9. This first one's okay, this one is too big. Okay, finally, I'll write my solutions nicely without this crossing out. How many solutions was I expecting? I was expecting 1, 2, 3, 4, 5, 6. How many did I get? There's my 6 solutions. Okay, so this is how you solve double or multiple angle trigonometric equations. Good luck. If you want some practice questions with solutions, have a go at these ones.